Now, if you take a look at number 46, we're trying to figure out the location of a fourth point on this quadrilateral that would make it into a parallelogram. Now, I've drawn a little parallelogram to the side of this graph just to visualize what my shape should look like at the end. Now, my goal is to figure out the fourth location, or the fourth coordinate of my point. So it should be this point down here. That's what's missing. Right now I have P, I have Q, and I have R. And I'm looking for that fourth coordinate. Now, I'm going to connect the points that I have right now in order to visualize this a little bit further. So I'm going to connect P to Q and Q to R. All right, now what I want to do is I want to find a line, or rather a point, that's going to form a line that's going to be parallel to QR. So I want to have another line on the left over here that's parallel. Now, how am I going to do that? I'm going to use slope. I'm going to think about what the slope is for QR, and then I'm going to use that slope to find my new coordinate from P. All right, now the slope of QR, starting at Q, I'm going to go down 1, 2, 3, 4 boxes, and to the right, 1, 2. So down 4 is -4, and then right 2. I'm going to do the same thing starting at P. I'm going to go down 1, 2, 3, 4, and then right 1, 2, and put a point. This is where my new coordinate S should be. Now, if I connect it, that's not a good line. Here we go, I'm going to connect it. Now this looks like a parallelogram. These opposite sides are going to be parallel, and I'm going to check the top and bottom as well. So PQ has a slope of -1 for my rise over 1, 2, 3, 4, 5. So it has a slope of -1 over 5. Let me make sure that my new bottom line also has the same slope so that I know opposite sides are parallel, and by definition, that would be a parallelogram. So the bottom line, going down 1, to the right 1, 2, 3, 4, 5. Okay, good. So -1 over 5. So yes, the top and bottom are parallel, and the left and the right are parallel. So we know this is a parallelogram. The question, however, only asks you for the y coordinate of point S. So the y coordinate is going to be at 4. So my answer is 4. All right, let's move on to the next question. Now this question at 55 is an application of the hinge theorem. Let's take a look at what these two triangles have in common. Now we know that this one tick mark side is congruent to the one tick mark side in the other triangle. And then we have the 2 tick marks and the 2 tick marks. Okay, so these two triangles have 2 sets of sides congruent. What's different, however, is the measure of the angle in between them. For the top triangle, it's 38 degrees. For the bottom triangle, it's 39. So when I see the difference in angle, that means the side across from them, the side across, opposite them, is going to be different between my two triangles. So if 39 degrees is my larger angle, then that means that the length of RT is going to be the longer side because it's across from the larger angle. And then 38 degrees, that's going to be across from the smaller, the shorter side. So if I were to write an inequality, because I'm looking here and a lot of them use an inequality, I would say that TR is my longer side. That's larger, so I open the mouth of the inequality wide to swallow up the bigger side, the TR. So TR is larger than QR. Now, part A says that they're equal. Nope, they are not equal. And notice it says RQ instead of QR. That's fine. It doesn't matter how you name the line segment as long as you use the endpoints. Now, the next one says TR is larger than RQ. That's exactly what we said, so I like that. Now, C says TR is shorter than RA. Well, we're not talking about RA at all. I don't even know where the A came from. It's probably a typo. They probably mean Q. But that's not going to be our choice either because TR is not smaller. And then last one, TR is equal to TS, which is equal to PQ. Okay, I know that TS and PQ are equal, but as far as TR, I don't know that. So it's not going to be choice D. Choice B all the way. All right, let's move on to the next question. Oh, and one more thing right before we do that, let's just write down in our notes, this is the hinge theorem. There were some questions in the past that we've done where we've looked for x values that would restrict the possible lengths of our different sides or our different angles. So that's an extension of this hinge theorem. You can look back over your notes and think about some of those problems because maybe that will pop up in the EOC. All right, so now let's move on. All right, now this question is a circle question. Now they're giving you a secant, which is the line that crosses into the circle, and a tangent, which is the one that just touches the circle at one point, and they're forming an external angle here at 44 degrees. Now they're telling us the two intercepted arcs of the circle are in the ratio 5:9. Now, one of them is going to be 5, one of them is going to be 9. And when we don't really know their measurements in this case, we're going to assign an x. So we're going to say this is like 5x to 9x because we don't really know what it's the multiple of. Because remember, we're always looking at how many sections fall in to a ratio. So we don't know how many sections are implied by your quote-unquote x value. So we're just going to call it 5x and 9x. Now, which of the two arcs that are intercepted would be your 5x and 9x? Well, the larger arc would be your 9x, and that would be your far arc. So this is your larger arc. That's going to be the 9x. It's always your larger arc. The far one is always larger. And then the near arc, that would be your 5x. So what do we do in these types of problems when we have an external angle of a circle? We always do our external angle formula. External angle equals the far arc minus the near arc divided by 2. So our external angle is 44. Our far arc is 9x minus our near arc of 5x divided by 2. Now to solve, we're going to multiply both sides by 2 to get rid of the denominator. Those cancel, so on the left side, 2 times 44 is 88. 88 equals 9x minus 5x. I'm going to simplify this. 9x minus 5x is 4x. And now I'm going to divide both sides by 4. So x is going to equal 22. Now that's x. The question asks you, what's the degree measure of the third arc? So what it's looking for is the measure of this last arc that we weren't even talking about yet. What I'm going to do is I'm going to figure out the measure of each of the arcs that I do know, the 9x and the 5x. So if I plug in 22 for 9x, I'm doing 9 times 22. I'm going to get 198 for the measure of the larger far arc. And then 5 times 22 is 110. So if I'm figuring out what's left over for that yellow arc at the top, all the arcs should add up to 360. So I'm going to subtract 360 minus 198 minus the 110. And whatever's left over, that's the measure of my last arc. So let me go ahead and do that. 360 minus 198 minus 110. I'm left with 52, which is my last arc. Okay, let's move on to the next question. Now for number 57, I know you didn't have to do it, but in case you want to know what these shapes are, and they do pop up eventually on your EOC, an octahedron is a shape that looks like the one right here on the left. It has 1, 2, 3, 4 sides at the top and 1, 2, 3, 4 sides on the bottom for a total of 8 faces. Now the question asks you what are the shape of each of the faces? Choice H. They're each equilateral triangles. All right, so in case you wanted to know what that's going to look like and what the answer would be, it's going to be choice H.